Hello, good morning.
Good morning from Sudan.
Good morning, good morning. Let's see. That looks pretty good. Let's see. Sudan, how are you today? And looks like Tahoka isn't quite here yet. They'll be coming in momentarily. Alright. 7:59. So, we did not get all the way through our lecture on Wednesday. We're going to wrap that up today and then also start looking at our next lesson. So, couple of things. I sent out an email to the facilitator letting her have access to a PDF file. Do y'all have the notes for 1.2? Sudan, you have the notes for 1.2?
Yes, we do.
Awesome. And just real quickly, somebody from Sudan, will you tell me who is all present?
Everyone's here.
So that includes Grant,
Hold your hand up.
Aubrey,
Yes, sir.
then Faith, and Arissa. Is that all, Sudan?
Yes, sir.
Okay, and Tahoka, I have Daniel and Patrick. Is that correct?
Yes, sir. We're here.
Cool. All right, so Tahoka, I sent an email to your facilitator with a PDF file for the notes for 1.2. And it's also available to you on Blackboard. So if you haven't printed those out yet, go ahead and get those printed out. We're going to be hitting those notes for 1.2 rather quickly. Now, to get started today, I want to go ahead and wrap up 1.1. I'll talk about the homework assignments. If you've already started the homework assignment and have any questions, we'll address those questions after we finish the notes. And then we'll hop into the notes for 1.2. And hopefully, if not today, then either on Monday or Wednesday, we'll be out of this rut where I'm halfway through one note and then starting another note halfway through class. Hopefully we'll find a balance rather quickly. So, on Monday, as a quick refresher, I'm going to go ahead and move on over to my document cam. We began our discussion on some basic geometrical ideas. We began with this concept of what is a ray. Described the difference between a ray and a line. An angle is the combination of two rays with a common endpoint called the vertex. And this combination of these two rays forms an angle, and we will often call that angle alpha, using the Greek letter A, alpha, where we describe an angle with an initial side and then a terminal side. So as the angle moves, in this case counterclockwise from right to left, we now have a terminal side. We can throw this angle now onto a circle. And when we throw the angle onto a circle where the vertex is also the center of the circle, we have what is called an intercepted arc of the circle. And then we can also throw this angle onto a coordinate plane where we have an x-axis and a y-axis. Typically, you're going to see that your x-axis is going to be the initial side of your angle, and then your terminal side will end up somewhere over here on the other parts of the coordinate plane. We often use the notation m of alpha to indicate what is the measure of alpha, and we declared that a circle is divided into 360 equal parts, and each part is called a degree. And then we began looking at a circle on a coordinate plane, and we started defining degrees in terms of the x-axis at this area going out towards, think about it as 3 o'clock on a clock face, we have 0 degrees, and then as we move counterclockwise, we end up a quarter way up to 90, 180, 270, and to 360, and so forth. And we can divide the circle into smaller degrees by increments of 30 or 45, and that's how we get these other degree measures. And then we went ahead and defined some other types of definitions: acute angle, obtuse angle, straight angle, right angle, quadrantal angle, and coterminal angles. And I believe this is about where we left off on Wednesday, talking about coterminal angles. And here's our definition for coterminal angles. If we have two angles, alpha and beta, and if they are coterminal, then they differ by a multiple of 360. So that means I can take the measure of angle beta and then declare that it is equivalent to the measure of whatever angle alpha is plus some multiple of 360. And so then we began a type of problem that you're going to have on your homework that says to find two positive and two negative angles that are coterminal with, in this case, 10 degrees. So we start off with 10, and remember, all we're having to do is add a multiple of 360. So that's why I just said, well, let's take 1 times 360 and add it to our 10 degrees, and then we get 370, which is coterminal to 10 degrees. And then we can add the next multiple of 360. So that's 2 times 360, which, by the way, 2 times 360 is going to be 720. So for finding that second coterminal angle, all you have to do is take that first angle and add to it 720 degrees, and then you'll get your second coterminal angle. And same idea here, you can find two negative ones just by subtracting 360, or in this case, this is the same as subtracting 720 degrees. Then we did that for another problem. Then we went through this process of determining whether or not two angles are coterminal, and we set up an equation. Is 20 and 380, are they coterminal? So we set up an equation: 20 plus k times 360 better equal 380, so long as k is an integer. And when we solve for k, we found that k is equal to 1. Since 1 is an integer, then we can declare that these two angles are coterminal, meaning they differ by a multiple of 360 degrees. Are the two angles 272 and negative 952 coterminal? Well, we set up an equation: 272 plus k times 360 equal to negative 952. We solve for k, and we end up with k equal to negative 3.4. Well, negative 3.4 is a number, but it's not an integer. So since k is not an integer, these are not coterminal. Alright, so what we're doing here is we're going to pick up where we left off. I went ahead and said, go ahead and tackle these next problems. Where does the angle 150 degrees lie? Well, if you need to start drawing a picture, that's fine. The idea is this. There's my coordinate plane. I know that this is 0 degrees, 90 degrees, 180 degrees, 270 degrees. So when we're talking about the angle 150 degrees, we're talking about some angle that exists over here. That's 150 degrees. Well, what quadrant is that in? That it is in quadrant 2. Then if you want to look at this angle 675, again, if you start drawing a negative 675, again, if you start drawing a coordinate plane, now since it's negative, we're going to go not in the counterclockwise direction, but we're going to go in the clockwise direction. So we know that one complete go around the circle is 360 degrees. Then if you kept on going, 360 plus 90 is a 450 degrees. Keep going, add 90, that's 540 degrees. Keep going, then that is 630 degrees right there, and 675 degrees is going to be somewhere in this area. So there are angles going all the way around, and what quadrant does that lie in? It lies in quadrant 1. Another way to look at this is you could think about, well, what if I do negative 675 degrees, and since we're talking about quadrants and each quadrant represents 90 degrees, you could divide this by 90, and what you end up getting is a negative 7.5. So the negative 7 means it covers 7 complete quadrants. So if I go around once, 1, 2, 3, 4, 1, 2, 3, did I say that right? 1, 2, 3, 4, 5, 6, 7. There's 7 complete quadrants, but because of the 0.5, it's going to get halfway through this next quadrant, so that's why it's in quadrant 1. And then if you do the same thing here with 960 degrees, either draw a picture, or if I take the 960 degrees and again divide it by 90, I get a 10.66. So what that means is my angle is going around 10 complete quadrants. So going counterclockwise, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have to account for the part, so we're now ending up somewhere in that quadrant, which is in quadrant 3. All right, moving on. So we can talk about angles in terms of the parts of an angle. In terms of decimals, we can say that we have 45.3 degrees. Or we can divide a circle into what are called minutes and seconds. So here's this basic idea. 1 degree is equivalent to 60 minutes. So here you have this kind of like a picture of a Pac-Man, if y'all remember that game, Pac-Man. And we have 1 degree right here. That little sector of the circle represents 1 degree. And in that 1 degree, there are 60 minutes. So 1 degree equals 60 minutes. You can start to equivalent that a degree is equivalent to 1 hour. 1 hour, 60 minutes, so 1 degree, there are 60 minutes. And in 1 minute, there are how many seconds? 60 seconds. Now, when we start doing some conversions, and we're trying to convert from degrees to degree minutes seconds or vice versa, yes, we need to know that in 1 minute there are 60 seconds, but rather we really want to know that in 1 hour there are blank number of seconds. And to find that out, you're just going to take 60 times 60. That gives me 3,600 seconds. Which, what is 1 hour? It is 1 degree. So that's where we get this other measurement in your notes, that 1 angle of 1 degree is equal to 60 minutes, which is also equal to 3,600 seconds. And again, when we're talking about angles, minutes and seconds aren't a measure of time, they're a measure of degree. They're a part of a degree. So we're going to go through and do some converting. We're going to convert from degrees, minutes, seconds to decimal degrees. So one thing I want to draw out to your attention real quickly, that might be better, is when we talk about degrees, minutes, seconds, we often use DMS to shorthand that idea, and decimal degrees are just things like 45.334, whatever. Alright, so let's go ahead and get going. We want to convert 35 degrees, 15 minutes, and 12 seconds to decimal degrees. Alright, so what we really have is we're just going to start off with our 35 degrees. And what we're adding to that degree is 15 minutes, and I'm going to put that 15 minutes over 1. But what we have to do is we have to work to convert this 15 minutes to degrees. And what we know is this, that in 1 degree there are 60 minutes. Now, instead of using that minute symbol, I'm going to write out minutes. And so what happens here is we're doing a conversion. Our minutes are going to cancel out as far as units go. And to do this calculation, we're going to pull out our calculator. We're going to take the 15 and multiply by 1. So 15 times 1 is just 15, but then divide it by 60. And we get 0.25. So what we now have is 35 degrees plus 0.25 degrees. We just converted our 15 minutes to degrees. Now, doesn't this make sense? 15 minutes. 15 minutes. If you look at a clock face, we know that on a clock face, the 3 o'clock represents 15 minutes, 30 minutes, and 45 minutes, and then 60 minutes, right? Well, what is 15 minutes? It's a quarter of an hour. And what is 0.25? It's a quarter of a whole. So doesn't that make sense? That 15 minutes is equal to 0.25 degrees. Now we have to do the same thing here because we have that 12 seconds. So we have 12 seconds over 1, and we got to convert that to degrees. And what do we know about 12 seconds? Well, back over here we already declared, what do we know about seconds? in that 1 degree, there's 3,600 seconds. So our conversion looks like this. 1 degree is equal to 3,600 seconds. So when we come back over here to our calculator, and we're going to do this math, we're going to take 12, divide it by the 3,600, and we get a 0.003 repeating. So you can say this now that you have 0.0033 repeating degrees, and then when you add up your 35, your 0.25, and your 0.0033, you get the following: 35.2533 degrees. Now, most of the time in my lectures, I'm going to go ahead and round to 4 decimal places. So I'm not going to put the repeating 3 symbol, the bar above the 3. I'm just going to go ahead and round it to 3 decimal places, so that's why I have 0.33, and then we're done. So that's how we can convert from degrees, minutes, seconds to decimal degrees. Now, we're going to work backwards in this next problem. We want to convert decimal degrees to degree, minute, seconds. So, here we go. What we have is we have 56.321 degrees. So that's equivalent to 56 degrees plus 0.321 degrees, right? Put that over 1, because we want to, the reason I put it over 1 is to make our conversion a little bit more visible, since we're dealing with multiplying fractions. Now, notice, and I forgot to do something up here. Yes, our minutes cancel out. Over here, our seconds canceled out, leaving you with just my degree units. So when we think about multiplying this by a converting unit, we need to think my degrees needs to cancel out with degrees over here. So that means degrees have to be on the bottom, and what we're going to have on top are minutes. And what do we know about minutes and degrees? We know that there are 60 minutes in 1 degree. Now, when you do your multiplication, 0.321 times 60, you're going to get the following: 56 plus a 19.26, and what is that? That is minutes. Double check the math real quick. 0.321 times 60, and we get the 19.26. Now, notice this is 19 minutes in part of a minute. In fact, it's 2/2600ths of a minute. Well, we need to convert this part of our minute to degrees. So what we now have is the following. We have the 56 degrees plus the 19 minutes plus the 0.26 minutes over 1. And guess what we want to do? We want to convert this 0.26 minutes to seconds. And how do we do that? Well, we have to multiply it by a conversion where we have 60 seconds in 1 minute. I'm sorry that this is getting really tight here. Does everybody see what I'm doing? I'm taking that 0.26 minutes, multiplying it by my conversion of 60 seconds per 1 minute. My minutes cancel out, and when I do the math, we get the following: 56 degrees 19 minutes, and when you take the 0.26 and multiply it by 60, you should get the 15.6 seconds. Now, we don't need to write our final answer with all these plus signs separating them. We can just write our final answer as the following: 56 degrees, 19 minutes, 15.6 seconds. And we are done. Now, once you get to a part of a second, you're back to decimal units. You're not going to go forth and try to convert this to a 60th of a second, like minutes and seconds and hours. We're just in decimal units right here, and then we are done. Okay, so we now have the ability to convert from degrees, minutes, seconds to degree, minutes, seconds to decimal degrees, and our ability to convert from decimal degrees to degree, minutes, seconds. Now we're going to conclude this lesson with just some basic computations. So what we have here is we have DMS measurements plus DMS measurements. We want to combine these together. Well, treat this just like you would any other old plain Jane addition. Take the 99 degrees and the 66 degrees, add them together, and you get 165 degrees. Take the 35 minutes plus the 48 minutes, and you get 83 minutes. And then take the 42 seconds and the 21 seconds, and you get 63 seconds. Now, we need to simplify this answer. Now, let's start back over here at the seconds. You ever heard of the joke, someone saying something like, oh, he's 5'12", right? You don't say 5'12", you say 6 feet, right? Because what's 12 inches? It's a foot, right? So you don't hear someone say, I'm 5'13" because, well, that 13 inches covers at least a foot, so you actually are 6 feet 1 inch. So coming back over here, when we look at that 63 seconds, that's we want to simplify that. Well, what is 63 seconds? Well, 63 seconds is 1 minute and 3 seconds, right? 63 seconds is 1 minute and 3 seconds. What about this 83 minutes? We know that there's 60 minutes in 1 degree, so there's at least 1 degree in here. That's 1 degree. How many seconds are left? 83 minus 60, isn't that 23 minutes? And then we still got that 165 degrees to contend with at the beginning. So now look what we have. The 83 minutes is actually 1 degree, 23 minutes. The 63 seconds is actually 1 minute, 3 seconds. Now you combine your corresponding units together. 165 plus the 1 is 166 degrees. 23 minutes plus 1 minute is a 24 minutes. And then we're just left with our 3 seconds. Alright, to tackle the next problem, what we're going to do is we need to be able to subtract the 31 minutes and the 15 seconds from something. Okay? So we're going to rewrite this 54 degrees. Now, isn't 54 degrees the same as 53 degrees and 60 minutes. Remember that joke I just said? 60 minutes. What is 60 minutes? It's 1 degree. So what do we really see? We have 53 degrees. We have 1 degree. That's a total of 54 degrees. Now the reason I'm doing this is the following. I can take 21 from the 53, and I can take 31 now from this 60. Before I didn't have anything to take it away from. It's like I'm borrowing. I have some zeros here that I have to borrow from, but we have to think in terms of degrees, minutes, seconds rather than decimals. Now, I have to have something to take the 15 seconds from. Well, we're going to do another quick thought. Let's look at that 60 minutes. We still got the 53 degrees. Isn't 60 minutes the same as 59 minutes and 60 seconds? Aren't those one and the same? What's 60 seconds? It's 1 minute. So combine that 1 minute with the 59 minutes, you get 60 minutes. And what are 60 minutes? 60 minutes is 1 degree, so combine that 1 degree with the 53 degrees, you get 54 degrees. Now, this is going to allow you to do some subtraction. We have 53 degrees, 59 minutes, 60 seconds. Subtract from that the 21 degrees, the 31 minutes and 15 seconds, and now we can do some math. This makes it really nice. What's 60 minus 15? It's 45 seconds. What's 59 minus the 31? It's 28 minutes. What's the 53 minus the 21? It's 32 degrees. And there's our final answer. So, sorry, I couldn't see that. Good job. So, what we had to do in this problem is we had to have something to take the minutes and seconds away from. That's why we went ahead and set up this borrowing technique over here. It's the exact same thing as saying you have 54 degrees, 0 minutes, and 0 seconds down here. And if you try to take the 21 degrees, 31 minutes, 15 seconds away, you can't take 15 from 0, and you can't take 31 from 0. So you have to borrow. That becomes 53. But remember, when you're dealing with degrees, minutes, seconds, this doesn't become 10. It becomes 60 minutes. But then you have to borrow from that, so that's now 59 minutes, and this becomes the 60 seconds. Then you can do your math. Alright, so let's do this last problem over here. We have 5 degrees, 19 minutes, 42 seconds, all divided by 3. So what I'm going to do is I'm going to approach this just looking at each part, the degrees, minutes, seconds divided by 3. So we have 5 degrees divided by 3 plus the 19 minutes divided by 3 plus the 42 seconds divided by 3. Alright, you don't really have to put the plus. I'm just kind of separating these out. Well, 5 divided by 3, I don't want the decimal value. The decimal value is going to trip you up in this problem. Rather, let's think in terms of the fractional value of this. 5 divided by 3 is the same thing as 1 2/3 of a degree. 19 divided by 3 is the same as 6 1/3 of a minute. 42 seconds divided by 3 is just 14 seconds. Now, let's think about a clock face. What is 1/3 of an hour? Well, 1/3 of an hour is 20 minutes. 1/3 of an hour is 20 minutes. So how many thirds do we have? We have 2/3. So what's two 20-minute segments? That's 40 minutes. So this is the same as 1 degree, 40 minutes. Again, what's 1/3 of an hour? It's 20 minutes. So this is the same as 6 minutes and 20 seconds. And then we still got to combine that with my 14 seconds. So what's our total here? 14 plus 20 is a 34 seconds. We have 6 minutes and 4 minutes. That's 46 minutes. And we have 1 degree, and we are done. All right, now, y'all received, and it's on Blackboard, a tentative course calendar for this semester. Looks something like this. If y'all didn't get one of these, look on Blackboard or email me and I'll send it to you. Now you'll notice that this has the assignment on it. Now, for the most part, your assignment is going to be reflected on here on the syllabus. But I'm going to declare this. Whatever the homework assignment is on the bottom of your notes, this supersedes the assignment that you see on the syllabus. So you see the difference. On the syllabus, it says 11 through 103 odd and 108. Well, this is just 11 through 103 odds, no 108. So, always be looking at the assignment that's printed at the bottom of your notes for your assignments. All right. Now, with that being said, here's your assignment, page 51, 11 through 103 odds. Now, this assignment will be due on Monday. And on Blackboard, and it should be popping up right now or momentarily, in the 1.1 folder. So here's my picture of a 1.1 folder. There is a quiz 1.1. Now, my intention was that we would be doing the quiz today during class. That's not going to happen. What you're going to do is you're going to take that quiz, you're going to print it out, and you're going to do it on your own time, and you're going to turn it in with the 1.1 homework. Okay? So, here's how things are going to get graded. 1.1 homework is a participation grade. If you completed the homework and you tried and attempted every single one of the problems, you get a 100 for that homework grade. We will be having in-class quizzes this semester. This first quiz isn't happening in class. It's a take-home quiz. So, that's a free, easy 100. Now, later on, maybe next week sometime, at the end of the week, we'll have another quiz. That will be done during class, and it will be turned in to me. Your facilitator will get it emailed to me or something like that, and I will grade that as it is. Homework assignments are, for the most part, a participation grade. We will try to spend some time at the beginning of each class addressing any homework questions that you have. There is no discrepancy in the amount of time that we have, the 3 days a week that I have with my in-class students. It's still the same amount of time. It's just y'all have 3 days, they have 2 days. So everything should run about the same. So real quickly, we are going to get into 1.2, but I have a question. Are there any current questions on the homework? Has anybody attempted the homework and there's something that just isn't quite making sense? Alright, so I'm going to go let's assume that by your silence that all is well, all is good in the neighborhood, and we are ready to go ahead and start talking about the 1.2. So, let's go ahead and pull out the 1.2 notes, and let's go ahead and start talking there. Let's see. Okay. In about 8 minutes or 7 minutes, set your timer or something. Just let me know. Try to make sure I don't go overboard and close class so that at a good time. Here we go. We're going to talk about radian measures of, it's just another way to describe how to measure an angle. And I thought of a pretty good illustration to describe a radian. And so we're going to just introduce ourselves to what is a radian. So I'm just going to come over here to another sheet of paper. What is a radian? Okay, so let's start off with a circle. There's the center of our circle, and this is my diameter. Alright, so if you know anything about geometry in circles, you probably recognize this formula. C is equal to pi d, where the circumference or the distance around the circle is equal to pi times the diameter. Now, if this has never been explained to you before, I hope you see this. We all know that pi is approximately 3.14, right? Well, what does that mean? What that means is if you were to take this diameter and you were to pull it out of the circle and make it all flimsy, so now you can have a curve of the diameter. What's going to happen is when you start wrapping that diameter around the circle, let's start here. When you start wrapping that diameter around, you're going to go around to about right there. So that's one diameter. Wrap it around, you're going to get about to probably about right there. That's one diameter. And then you're going to wrap it around again, and you're going to get to about right there, and that's one diameter. So how many diameters did I get? 1, 2, 3. But there's this little bitty leftover part. And that little bitty leftover part is at 0.1428 whatever part of pi. It keeps going and going and going, right? So you have 3.14 diameters wrap around the circle. Alright? That's how we get this idea of pi. Now, let's talk about radians. Let's not take a whole circle, but let's take half a circle. There's half a circle. And then, let's not take a whole diameter, let's take half a diameter. From here to here, that's called a radius, or RAD for short. Now, guess how many times, if I were to take this radius out and, pull it out of the circle and make it all nice and bendy, call that one radius, guess how many times that radius is going to wrap around this half circle? 1 radius, 2 radiuses, another radius. You're going to get all the way to right here. There's another radius. And we have 1. You can see it right there. 1, 2, 3 radiuses. And what's that? Guess what that little bitty leftover part is? Guess what it's equal to? 0.14. So what we see is the following, is that in a half circle, in this half circle, there are pi radians. And this is going to develop our first initial idea about degrees and radians. So, before I say my next statement, I want you to get this idea in your head. A radian is really a measure of distance. How far is it from here to here? That's 1 radian. It's a measure of length from here to here. It's not a measure of the angle, but there is a relationship between this measurement of length and the corresponding angle, and here it is. If you have a straight line, we know by definition that a straight line has 180 degrees, right? A straight line has 180 degrees. That means from here to here is 180 degrees. Well, guess what that shape is? That's a half circle. So what do we have? We have that 180 degrees is the exact same as pi radians. And that develops our first definition on your notes right here, that 180 degrees is equal to pi radians. So, yes, there is a relationship between degrees and radians. Radians can be a measure of degrees, but they're also a measure of distance. So, looks like I got time to do a couple of quick examples. Let's convert 1 radian to a degree. Convert 1 degree to 1 radian. So we have 1 degree over 1. And we want to convert this to radians. So what we need to think about is we need to think about the fact that degrees need to be on bottom. My radians need to be on top, so that way my units cancel each other out. And what do we have about our relationship? Well, there are pi radians in 180 degrees. So then I'm going to pull out my calculator. I'm going to go over here. I'm going to hit pi. I'm going to divide it by 180. I'm going to hit enter. And what do I have? 0.01745 0.0175 radians. So 1 degree is equal to 0.175 radians. And we can go from radians to degrees. We have 1 radian over 1. We want to multiply it by a conversion where we have radians in our denominator, degrees in our numerator. What do we know? There are 180 degrees in pi radians. What units are going to cancel out? Radians are going to cancel out. So when I do my math, I have 180 degrees divided by pi, and you get 57.2958 degrees. Now, we're going to pick up here on Monday, dealing with how to convert other degrees to radians and vice versa. So, at this point, all you have for a homework assignment, just looking at my clock, I got about a minute left. We probably could have done those problems, but we'll start there on Monday. So right now, all you have assigned is the 1.1 homework and the quiz that is available to you via Blackboard. I also sent it out to facilitators. I will be emailing the facilitators probably to get at this point, yes, it's due on Monday, and I will get those either graded to me on Monday or Friday of next week. But anyways, always feel free to email me if you have any questions with the homework. Any last thoughts before we conclude today from y'all? All right, well then have a great weekend.